Bismillahirrahmanirrahim and Assalamu alaikum. I hope that you all are doing well. This is week 4, day 1 of class 9th physics, and today we are going to review the exercise of unit number 5, that is gravitation. So let's get started. First question we have in unit number 5 is multiple choices questions. So let's study about the first statement, which is stated as Earth's gravitational force of attraction vanishes at 6400 km. Option B, infinity. Option C, 42,300 km. And option D is 1000 km. What should be the answer of this MCQ? Yes, the answer is infinity. It means that there is no place where we can go and find that a gravitational force from the earth to that place is zero, no matter how far away that place is. It's because the gravitational force of attraction never dies. Yes, it decreases as we move away from the earth, but it never ends. Next MCQs is value of G increases with increase in the mass of the body, increase in altitude, decrease in altitude, or none of the above. We know the formula of gravitational acceleration, that is G is equals to capital G me divided by r plus h whole square, where me is the mass of the earth. They are asking that where does G increases? When G increases, is the mass of the body increase? No, it doesn't happen because in the formula we don't have the mass of the body. Second thing is increase with altitude. Altitude mean height. As you can see from the formula that GH is inversely proportional to height. That if we are increasing the value of G, the height or altitude is decreasing. So the correct option is option number C, that if we increases the value of G, the altitude decreases. Next is MCQ 3, and it's stated as the value of G at a height 1 earth radius above the surface of the earth is 2g, 1 by 2g, 1 by 3g, and 1 by 4g, where g is the gravitational acceleration. So we know that the formula of gh, which is gravitational acceleration at a height, is equals to gme divided by r plus h square. That we want to know that what would be the change in the g if we change h as 1 earth radius, which is equals to r. We have discussed about it in the previous topic, which was mass of the earth and variation of g with altitude. That if we change our height with the 1 earth radius, we'll get the answer as 1 by 4th g. That if the height is 1 earth radius, then the value of g will be decreases by 1/4 its original value on the surface of the earth. So the answer is option D. Fourth MCQs is the value of G on moon surface is 1.6 meter per second square. So G is equals to 1.6 meter per second square. What would be the weight of 100 kg body on the surface of the moon? So the value of G on moon is 1.6 meter per second square. We have to find out the weight, and the mass is 100 kg. So as we know that weight is equals to mass into gravitational acceleration. By multiplying both, we'll get the answer as 160 Newton, and the option is B. So the right option is B. Next MCQs we have here is MCQs number 5. And the MCQs is the altitude of geostationary orbits in which communication satellites are launched above the surface of the earth is. We have discussed about it in artificial satellites that the height of the geostationary orbits is about 42,300 kilometers from the surface of the earth. So the right option is D. 6.1. The orbital speed of low orbit satellite We have discussed about it in the motion of artificial satellite that a satellite revolving very close to the earth has a speed of nearly 8 kilometer per second. If we remove the prefix of kilo, we'll get the answer as kilo means 10 raised to the power 3, or we can also say it as 1000. So 8 kilometer per second, which is equals to 8000 meter per second. So the right option here is D. Moving on to our next task, that is to review the short question, and the first short question we have here is 5.2, which stated as what is meant by force of gravitation. As we know that gravitational force is a force that attracts any two objects with a mass, we call the gravitational force as an attractive force because it always tries to pull masses together. It never pushes them apart. So that is gravitational force. 5.3 is, do you attract the earth or the earth attracts you? Which one is attracting with a larger force, you or the earth? So according to Newton's law of gravitation, or we can also say it as Newton's third law of motion, we both are attracting each other. As our body is very small as compared to the earth, so we attract the force, the earth, with a very small and insignificant force. Therefore, it is not felt by us. Whereas the mass of the earth is very large, so the earth attracts us with a larger and significant force. 5.4. What is field force? As we know that if we throw a body upwards, the velocity of a body decreases, and on returns its velocity goes on increasing. This is due to the gravitational pull of the earth acting on a body whether the body is in contact with the earth or not. So such a force is known as field force. 5.5. Why earlier scientists could not guess about the gravitational force. Earlier scientists could not guess about the force of gravitation between two masses because of its very small value. It could be detected only by a very sensitive instrument which were not invented at that time. Now we have an instrument called as gravimeter, through which we can determine the value of G, and Newton's law of gravitation, through which we can derive or determine the value of force of gravitation. 5.6. How can you say that gravitational force is a field force? We have discussed about it in gravitational field, which was our previous topic, that as the field exists all around the earth, so gravitational field becomes weaker and weaker as we go farther and farther away from the earth. So gravitational field is a field force. Gravitational force is a field force. 5.7. Explain what is meant by gravitational field strength. In the gravitational field of earth, the gravitational force per unit mass is known as the gravitational field strength, and its value is equal to the value of G, which is 10 Newton per kg. 5.8. Why law of gravitation is important to us? Obviously, the law of gravitation is very important to us because it is important in understanding that why Earth revolves around the Sun. It also explains the phenomena of gravitational force between the planets and the stars, and the rotation and revolution of heavenly bodies and galaxies. So, all in all, that law of gravitation is very important to us. 5.9. Explain the law of gravitation. We have discussed it in the first topic of Newton of unit number 5, that is Newton's law of gravitation. You can define the Newton's law of gravitation, write its formula, and draw the diagram. 5.10. How the mass of the earth can be determined. Mass of the earth can be determined by this formula, that ME is equals to R square G divided by capital G, where R is the radius of the earth, G is the gravitational acceleration, and capital G is the universal constant of gravitation. 5.11. Can you determine the mass of our moon? If yes, then what do you need to know? Yes, we can determine the mass of the moon by using the law of gravitation. we have discussed the formula of to calculate the mass of the earth, so we can use that formula and replace E as m. So the formula will be mm is equals to r square gm divided by g, where mm is the mass of the earth, mass of the moon, r is the radius, gm is the gravitational acceleration on moon, and capital G is the universal constant of gravitation, whose value is 6.673 multiplied by 10 raised to the power minus 11 Newton meter square per kg square. 5.12 and 5.13. Why does the value of G varies from place to place? Next question is, explain how the value of G varies with altitude. Both questions have the same answer because they are asking you about the variation of G with altitude. We have discussed it in the topic of gravitational field and variation of G with altitude. The formula was GH is equals to GME divided by R plus H square, and GH, which is gravitational acceleration, it is inversely proportional to the height. It means that if G increases, then the height decreases, and if the height increases, then G is decreasing. So you can explain this formula, and you can say that if we increase the height, the value of G decreases. 5.14. What are artificial satellites? So artificial satellites are man-made objects that are sent into the space. We have several satellites, artificial satellites, such as communication satellites and geostationary satellites, and we have several satellites like artificial satellites like Hubble's telescope. 5.15. How Newton's law of gravitation help in understanding the motion of satellites. The motion of satellites is due to the gravitational force of Earth, which provides the necessary centripetal force to move the satellite into the circular path. The satellites are free-falling states, and a free-falling state and have acceleration equals to the g due to Earth. 5.16. On what factors does the speed of a satellite depends? As we know that the formula of orbital speed, that is v0, is equals to under root of g r plus h, where g is the gravitational acceleration, r is the radius, and h is the height. So orbital speed depends upon these three factors. 5.17. Why communication satellites are stationed at geostationary orbits? So as we know that communication satellites take 24 hours to complete one revolution around the Earth, and Earth also takes 24 hours to complete one rotation about its axis. So both are taking the same time. So communication satellites appear to be stationary with respect to Earth. So this is the reason due to which the orbits are known as geostationary orbits, and the communication satellites are known as geostationary satellites. So these were the numeric short questions as well as the MCQs. If you have any question, you can ask it into the comments below. Hope you understand. Allah Hafiz.